Okay, the first question I'm going to go through today, it gives the following question. It says that the radius is 16 centimeters here. This is 0.8 radians. If it's in radians here, make sure your calculator's in radians before you go any further. So I can see the little D there on mine. I'm actually in degrees, so shift and mode, then 4 to select it into radians. It says, find the area of the region BDC. So BDC is this thing here. So the first thing I'm going to try and do is come up with a formula so I can work it out and then do those little individual bits. So the area of BDC would be equal to this entire segment here, well, this entire sector, sector would be area of A to B to C, and then I want to take away this triangle A to D to B. Okay then, now, things that I'm noticing here, if that's 7 centimeters here, the whole thing's a radius because it's going from the center to C, so that must be 9 centimeters because 7 add 9 makes 16. So that might make it useful for this question, it may not. Area of ABC, this bit here, this sector, would be 0.8 out of 2 pi, because 2 pi is like 360, times by pi r squared. Now the radius is 16, so I'm going to put 16 squared straight in there, and I can see there that my pi's cancel, and take away the area of A to B to D. So that's this triangle here, and for that I'm going to use a half AB sine C. So that is a half of 7 times 16 sine 0.8, and then it's literally just writing that into my calculator. If I wanted to take any shortcuts, I could say that's 0.4 instead of 0.8 divided by 2 into the calculator, times by 16 squared. I might leave it as that. I'm going to stick brackets around that in my calculator just so I'm safe and I don't have anything go wrong in the next bit. Minus a half, I'm going to put in as 0.5 so it's easier for me to write in, and then 7 times 16 times sine 0.8, close my brackets, and I get the answer 62.2 centimeters squared to 1 decimal place. Okay, then for the next bit, part 2, it says find the perimeter of the region BDC. So to find the perimeter of that, to B to D to C, I already know the 9 centimeters, I already worked that out. I need to work out this bit, which is part of the circumference, so 2 pi r is the whole circumference. I'm only going to need part of that, so I'm going to need my angle, which I'll just call theta for now, out of 2 pi times by that. 2 pi's there will cancel, giving me theta r for the arc length. And I need to know what this side here is. Now here I've got a triangle with 2 sides and an angle given. So if we call that little a there, because it's opposite capital A, I can use cosine there. So I'm going to start off by doing that. So that would be a squared equals the other 2 squared, so it's 7 squared plus 16 squared, minus 2 lots of the other 2 times together, and then the cosine of that angle, so cos 0.8, and then whatever that answer is, I will square root it to find out what my answer for A is. Similarly now for my arc length, so from B to C, I just want to do the radius times by the angle, so that's going to be 16 times by 0.8. So B to C, that's nice and easy to work out, should just do that quickly. B to C is coming up as 12.8 centimeters, not even to 1 decimal place, that's just what the answer is. And then for the other one, it is going to be 7 squared plus 16 squared minus 2 lots of 7 times 16 cosine of 0.8, close my brackets, comes to 148.9 blah blah blah, and then I'll square root that answer to get 12.2 centimeters to 1 decimal place. Technically I shouldn't round that answer, so I won't in my next bit. I'll use the answer in my calculator, the answer button. So I'll say perimeter would equal this 12.2 and show that that answer continues there, and I'll write it down, plus the 12.8 plus the 9 that I worked out straight away, because that would be my perimeter of this thing here. Okay, and then that is going to be answer plus 12.8 plus 9 comes to, and that's filling me with confidence looking at an answer like that, because it feels like it's more or less been made to be that. It probably has been in that case. Okay, so that's question 1 done on arcs and areas and radians in general. Over the page, this was the second question for Monday. So this was the geometrics terms. Okay, first of all, it says the second term, so U2 is equal to 192, and it tells you that the third term is equal to 144. So it's actually reduced as it's gone on. So that tells me that I'm going to have a ratio that is smaller than 1, which I sort of knew was coming up because it told me the sum to infinity, or to find that, and I can only find that when the ratio is less than 1. Okay, so second term you should know is AR, so AR is equal to 192. The third term would be AR squared is equal to 144. I'm going to call this equation 1 because it has the biggest power. You don't have to call them this way around though. I'm going to call this equation 2. I could have called them the other way around. But it makes your life easier if the one with the biggest power is up on the top to divide. Okay, when we looked at geometrics, we always said try and get things cancelled out by dividing, because a geometric series is multiplying. So to cancel them out, let's divide them. So we're going to get AR squared is equal to 144 divided by, and this side would be AR, and this side would be 192. A divided by A cancels straight away, and then R squared divided by R leaves me with just R, and then 144 divided by 192 comes to 3/4. Okay, and part B, find the first term. I'm going to sub R equals 3/4 into, I'll do it into 2 because that's the easier one. So 3/4 times by A, not R, because that's what R was. Just switch the order, doesn't matter when you're timesing. For instance, 3 times 4 and 4 times 3 give the same answer. So 192 would equal, A would equal 192 divided by 3/4, which I'll write as 0.75 to make it look a little bit neater. So A is equal to 256. Part C, sum to infinity. It's given in the formula booklet, so there's no excuses for getting this wrong. A over 1 minus R, so that would be 256 divided by 1 minus R. So 1 minus R would be 1 minus 0.75, so 0.25, which is sum to infinity is equal to 1024. Oh, that's 1024. Okay, now the next bit, part D, is quite sneaky. So I'm going to put a line down here because the way that we've solved this in class doesn't actually make any sense, and you'll see what I mean. I'll show you why we need to know the way of taking logs of both sides, but this is a very, very, very rare occasion. Okay, now it says, for part D, it says, find the smallest value of n for which the sum of the first n terms of the series exceeds 1,000. So we know it only just gets to 1,000 when you've got the infinity term, so it wants to know what value of n until it gets to 1,000. So the sum formula, Sn, is equal to a1 minus r to the n over 1 minus r. Okay, that's what we should know, that's what we've learned for that, and we want that to exceed, so that means it's got to be greater than 1,000. Okay, so the way I would ordinarily do this, and then my answer doesn't make any sense, is A is 256, so I'm going to times that by 1 and times it by r, so it would be 256 times r, so I'm going to leave this as 0.75 because it maybe makes things slightly easier when I'm putting stuff into a calculator, to the power of n all over 1 minus 0.75 is greater than 1,000. Okay, and this would be 1 minus 0.75 would be 0.25 times by 1,000 is 250. Okay, so that's 250. Now I don't like my thing with the n, I don't like that being negative, so I'm going to switch that with this side. So I'm going to get 256 minus 250 is greater than 256, 0.75 to the n. I'm then going to get 6 divided by 256 is greater than 0.75 to the n. And then ordinarily what I would do is I would take log of base 0.75 and say 6 over 256 is greater than n. When I put that into my calculator, we get the right answer, but something happens weird with the inequality that I can't quite explain doing it this way, but I can explain it doing the other way. So I get the answer 13.404 blah blah blah. 13.04 is greater than n, Now I get the answer now, 13, so n is less than 13.04, blah, blah, blah. Now, if I put in a number that is less than 13.04 into this formula here, so where was it, into this thing, so if I do 2.256 minus 250, and then, hang on, what am I messing up here? I want it into this form here. So 256 minus 256, 0.75 to the power of n. Now I'm saying that n is less than 13. That's what my statement here is saying. So less than 13.04 would be, next nearest number would be 13. So I'm going to use 13, and then 1 minus r would be 1 minus 0.75. I get that answer. An answer that is less than 1,000. The question said exceeds 1,000. So what I did, the way I first did it, was just say, well, it's clearly n is equal to 14 then. But my algebra lets me down. It doesn't give me the answer that I wanted. So you can see when it does go to 14, it does exceed it. So I'm going to go all the way back to this line here. Okay. Now where you get, sorry, this line here, where you get this this 6 over 256 is greater than 0.75 to the n. If you take logs of both sides, so we take log 6 over 256 is greater than log of 0.75 to the n, that is then going to give me log 6 of 256 is greater than n log 0.75. So then I'm going to take the log 0.75 over. Now, when I divide by negatives, what happens is I flip the inequality, and if I do log of 0.75, I get a negative answer. So when I take that over, I'm actually dividing by a negative number. So if I'm dividing by a negative, it must switch the inequality. So I'm going to say log, where is it? Log of 6 over 256 divided by log of 0.75 comes to exactly the same answer as I had before. So like I said, we didn't do anything majorly wrong before. 13.04 blah blah blah, and then I'm going to get the n onto the left hand side so I can read it, but if I flip the n side I must flip the inequality, then I do actually get the right algebra. So I can't quite think about why it's not coming up that way, but I can when I take logs of both sides, so that's why it's important we know both sides. Okay. For the next set of questions, these were the ones to be done on Tuesday. So don't worry about doing these unless it's Tuesday. If it's Monday and you look at this video, stop watching now. There's no point. Don't do all these questions because I'll be doing them in class tomorrow. I'll certainly be showing them in class tomorrow. So for A, find the coordinates in the centre of C. We should be pretty quick at this now, so I'm going to do it very, very quickly. I'm not really going to explain what I'm doing here. I'm hoping you're going to start picking up what I'm doing. So get that. So the centre was -2, 1, and the radius was equal to the square root of that, which is 4. So that's A and B done. Okay. If you're unsure on that, you really need to be doing a bit more revision on these. That's pretty straightforward. For the next part, for part C, I thought this was a very, very good question. It said the coordinates of the point C where it crosses the y-axis. Now we know something if it's telling us what if the circle's crossing the y-axis. At the y-axis, x is equal to 0. Okay, so you sub x equals 0 into that formula. So you sub x equals 0 in equation of C. So I'm going to get 0 squared plus y squared plus 4 lots of 0 minus 2 lots of y minus 11 equals 0. So then I get y squared minus 2y minus 11 equals 0. And at first, when I looked at that, I thought, oh, I don't get an answer I can factorise here. It gives me a bit of an issue. But then look, it says, give your answer in simplified surds. So A equals 1, B equals -2, C equals minus 11. So it's going to be minus B, so minus -2 is just 2, plus or minus the square root of B squared, so -2 squared is 4, minus 4 lots of AC, and then all over 2A, so all over just 2, then 2 times 1 is that. So then I'm going to get 2 plus or minus the square root of 48, all over 2, and then I'm just going to sit that into my calculator and see what I get. You could try and work it out in your head if you wanted to, but if you get it wrong, you've got to calculate for this paper, so I wouldn't run the risk if it was you. If it was me, sorry. When I added it, I got the following. So y equals that, and when I minus it, I guess I'll just get the same thing, but with a minus. There we go, yeah, 1 minus 2 root 3. Okay, so there's my answers. Okay, now the next question, my gut feeling is part 2 here of A, I don't think we'd actually get it asked, okay, but it's really, really sneaky, and I've never seen this come up on the WJC course, but I will show you nonetheless. It will certainly make you think though, and it's definitely going to bend your head a bit, okay. Now the first bit, it says, given that alpha is the acute angle such that tan alpha is 2/5, find the exact value of cos alpha. Okay, now you should know how to do this from mechanics anyway. So if tan alpha is equal to 2/5, what you need to do is you need to picture a right angle triangle. Okay, mark the right angle, doesn't matter which angle you take, I usually take this one here, it really doesn't matter though. Tan, if you think of the word SOHCAHTOA, it tells us that it is opposite divided by adjacent, so the opposite must have been 2, the adjacent must have been 5, this is a right angle triangle, so 5 squared plus 2 squared is 29, and then the hypotenuse would be the square root of that. Okay, therefore, to find the cos alpha must be equal to, SOHCAHTOA would be adjacent divided by hypotenuse, so it would be 5 divided by root 29. Okay, and similarly here I could also say that sine alpha is equal to 2 over 29. These are all the same values. If you do cos to the minus 1 of 5 over root 29, you should get exactly the same answer to sine to the minus 1 of 2 over 29 and tan to the minus 1 of 2/5. Now, part 2 is the bit that's really hard, and like I said, I don't think this would come up. And the key word here is it tells us it's the obtuse angle. Okay, so if it is the obtuse angle, I'm thinking of all silly tomcats here. Okay, if it is an acute angle, it would be no issue. It's just like the one that we did, and that's what we usually get asked. But if it is the obtuse angle, then it's this angle here that I'm interested in the all silly tomcats. Okay, now truth be told, I don't do a huge amount of things differently here. So if sine beta is equal to 3/7, then again, I visualise that in a right angle triangle. I'm going to choose exactly the same angle, because I said I'd normally choose that one. And then sine is is opposite over hypotenuse. So that must have been 3, that must have been 7. So then to work this out would be 7 squared, take away 3 squared, so that is root of 40. So if you look at that, and in terms of what we would get, what's it want? It wants cos beta. So cos beta would be equal to the adjacent divided by the hypotenuse. So root 40 over 7. Okay, but bear in mind I'm here on my diagram, and if I was going through here, then the only reason why I do that is if I have a minus answer. I go through all and cos if it's positive, I go through sine and tan if it's negative, and I have to be going through that one because they told me it was sine, it was the obtuse angle, so I must have been going through that one. So you just need to stick a minus in front of the answer there. Okay, it's not the most obvious thing in the world. I don't think it will come up. I've never seen it before. I had to think about that one as well. Okay, finally for part B, if we look at the triangle here, that's A, that's little a, that's the angle they want, and that's the angle opposite. So we're just going to use the sine rule here, 2 angles, 2 sides. So I'm going to do, because I want the angle, I want to get an expression for, what does it say, find the exact value of sine y. So sine y over the opposite side would be equal to sine 60 over the opposite side. So then I'll take sine y, I'm not even going to take the sine over, I'm just taking 6 up to the top here and multiplying over 8, and then literally just stick that into the calculator and see what we get. So 6 sine 60, and put that over 8. Now, first of all, I get a really strange answer. I was working in radians before. Make sure you're in degrees for this. This says 60 degrees by there. Okay, so it's important that you make sure you're in degrees mode. Press equals again, and this time I get a much simpler idea, and it even said simplifying your answer. Well, that looks pretty simplified to me. So 3 root 3 over 8. Okay, final question. Final question is logarithms. So your logarithm knowledge needs to be pretty good here, and this is definitely one to be thinking about. But it's nothing too bad. You should be able to do all of this stuff, and if you don't, then you need to do some logarithms revision. Okay, so log base 2 of x plus 15 squared minus log base 2 of x. Now, I don't want to put that equal to 6, so I want to get both sides to be log base 2, and then I can cancel out the logs. Okay, so log base 2 of what will give 6? Well, you should know if you do 2 to the power of 6 gives 64, and then it says 2 to what power gives the answer 64. So if I do log base 2 of 64, guess what the answer is? It's 6. Okay, so you should know how to do that. If you didn't know how to do it, you need to do a bit more revision on logarithms before next Wednesday. Okay, now when I'm taking away logs, it means I'm dividing, so I can say log base 2. Now I'm actually going to expand that thing there. That's going to give me x squared plus 15x plus another 15x plus 225 over x is equal to log base 2 of 64. Okay, now I've got my wish, I've got log base 2's both sides, so they cancel each other out. I'm going to take that x round to the side and times it by the 64. I'm going to simplify it all in the same go. So x squared plus 30x plus 225 is equal to 64x. And then finally, bringing the 64 over will give me x squared minus 34x plus 225. Okay, and then that's what they wanted up there, isn't it? It's the same line. Okay, hence solve that equation. Well, that is just asking me to factorize this thing here. I've already done all the hard work here. Okay, so ideally, I'd like to look at that and think, oh, I know what number goes into both. Worst case scenario, I'm just going to use quadratic formula again, as I already have in this video. But let's think about the obvious options that make 225. Well, obviously 1 and 225, but that definitely goes nowhere near this minus 34. 5 goes into it because it ends in 5. No idea how many 5s go in, so 225 divided by 5 is 45. No, that's not going to do it. Maybe 15. 225 divided by 15 is, of course, it's 15. We just did that, didn't we, to square it. Last one that I can see, obviously, 2, 2 and 5. 2 add 2 is 4, add the 5 is 9. That means 9 goes into it. So divided by 9 is 25. So 9 and 25. Yeah, that does it, doesn't it? 9 and 25. So it would be minus 9 and minus 25 because it's got to be minus 34. Okay, so x is equal to 9 or x is equal to 25. And then if you wanted to, you could check that by subbing in one of those into the very, very, very top equation. I might choose 9 and just check it quickly. So 2 log base 2 of 9 plus 15 minus log base 2 of x. So I'm using 9. Now that should come to 6. If it doesn't give me 6, then I've gone wrong. But it gives me 6, so I'm right. Okay. If I wanted to now, I could just go over and use the replay button, delete the 9, change it to 25 and 25 and cross fingers. Yep, 6 again, so now I'm right. Okay, lovely. Hopefully they've been useful, and hopefully that's meant we've had a little bit more time in class looking at some C1 stuff this week. Good luck for your exams.